Hello and welcome back to Tech. In this video, I'm going to show you to make an earthquake model display with using a few simple parts, such as a Tip122 Darlington transistor to control the speed of a DC motor. Let's get started. And these are the items you're going to need to make for this project. The items you're going to need is some stretched out metal springs, some cat bells, some cardboard cutout flowers, which will go onto these metal springs, which will attach to these cardboard pieces. And as you can see, I've already designed these cardboard houses. This will be part of the display. And these are the electronics you're going to need to make for this project. The items you're going to need: a 9-volt battery clip, a 9-volt battery, a Tip122 Darlington transistor, a 10K Ohm Potentiometer, a nut, which will be glued to the CD, and the CD will attach to the CD DC motor. And you're also going to need a Perfboard, a slide switch, and a Rectifier Diode. And this right here is the schematic that you're going to need to make for this project. Now, let's go ahead and assemble this project, and let's get started. First, I'm going to take this Perfboard, take the 10K Ohm Potentiometer, put it in place, bend over the leads so that way it stays in place. Solder it into place, and now press down the potentiometer and remelt the solder so that way it can be flush with the board. And now solder in the rest of the pins. Next, take the Tip122 Darlington transistor and place it into the Perfboard. And now solder it into place. This is the base, collector, and emitter. Next, connect the base of the transistor to the center pin of the potentiometer. Bend over the base, and now solder bridge it to the center pin of the potentiometer. Next, cut off the excess of the collector. And now take this wire and solder it to the collector. And then solder the other end of the wire to one of the end pins of the potentiometer. Next, I'm going to take the diode and I want to connect the cathode of the diode next to the potentiometer. Place it in just like this. And now bend over the cathode lead of the diode over to the free lead of the potentiometer. And then bend over the anode lead. Solder the cathode over to the potentiometer. Solder bridge it together just like this. Cut off the excess. And now solder the anode into place. Next, I'm going to take the 9-volt battery clip. And now take the negative of the 9-volt battery clip and connect it to the cathode of the diode. Next, I'm going to take the emitter of the transistor, cut off the excess. Next, take this wire and solder it to the emitter of the transistor. Solder it into place. Next, take the positive of the 9-volt battery clip, and I want to connect that over to the collector of the transistor. And I decide to place it right here where the potentiometer is, which is connected to the collector of the transistor. And there we go, soldered into place. Next, I'm going to take this piece of cardboard and then take these 4 pieces of cardboard Next, take some hot glue, go across the cardboard like this, and then take this piece of cardboard and put it into place. Add some more hot glue to glue it into place better. And repeat the same process 3 more times, and I want it to look just like this. Next, I want to take this CD and the CD DC motor, connect the two together, add some super glue, spray some activator and glue it into place. Next, take this nut and glue it into place. And the reason for doing this is so that way when the CD rotates, the center of mass will be incorrect, which will cause the entire device to vibrate. And as you can see, I added more glue to the CD. The reason for doing this is so that way when it rotates, it doesn't violently fly off. Doing this will hold it in more secure. Next, I'm going to take these wires and solder it to the DC motor. Next, take a generous amount of hot glue and glue it to the DC motor. And place more hot glue directly to the cardboard. And then glue the two parts together. Next, what I need to do is place it on top, just like this. Next, take some hot glue and put some hot glue on these cardboard edges. And now take this top part and glue it together. And there, should look just like this. Flip it over. Add some more hot glue to secure it in place better. Next, take the wire that is soldered to the emitter of the transistor and solder it to the center pin of the slide switch. Next, take one of the wires from the DC motor and solder it to the slide switch. Next, take the second wire from the DC motor and solder it to the anode of the diode. Cut off the excess. And there, the circuit is now complete. Next, I'm going to take some hot glue and glue the circuit into place, and also glue the slide switch into place. And there, it should look just like this. Next, I'm going to take a 9-volt battery, take some neodymium magnets, put it on the battery, put some hot glue on the neodymium magnets, plug in the 9-volt battery, and put the 9-volt battery into place. And wait for the glue to solidify. And as you can see, the glue is now solidified. And now if you wanted to change the battery, you can just simply remove the battery and place it back on the magnets. And when it vibrates, the battery will stay in place. Next, take the cardboard houses and put them into place. Take some hot glue and put some hot glue on the cardboard houses. Put them into place. And there, should look just like this when complete. Now let's go ahead and test out the circuit. Turn on the switch and turn the potentiometer. And as you can see, the CD is now spinning and is causing this to vibrate. And as you can see, this display is moving too much, so what I'm going to do is take this rock and hold it down. And an idea I thought of, want to add some bells to it. So that way it can shake and ring. Now, the bells are now glued into place. Let's have a listen and see how this sounds. And now it's time to make the flowers, and as you can see, I'm going to put it together just like this. Flip it over, put some hot glue and glue the spring into place. Put the two petals together and glue them together just like this. Add some more hot glue to glue it to the spring. Wait for it to solidify, and hold everything together. And there, the flower should look just like this, and when it vibrates, it'll cause the flower to wobble back and forth. Next, take some hot glue and glue the flower into place. And there, it is now glued into place. Now turn on the circuit. And as you can see, when it vibrates, it'll cause the flower to shake back and forth. And now I glued all the flowers into place, and there, the project is now complete. Okay, so now I found some weights to weigh it down. Now, let's go ahead and test it out. Turn on the switch, and slowly turn the potentiometer. as you can see, there's a small earthquake. And now a bigger earthquake. Interesting. As I adjust the speed of the motor, you can see the different frequencies. High frequency reacts to here, medium, low frequency. Let's see what it looks like on maximum. And there you have it. Now you know how to make your very own DIY earthquake model display with using a Tip122 Darlington transistor, which will control the speed of a DC motor, which will then control the frequency of the earthquake. Thank you for watching SciTech Tech. I hope you learned something new, and don't forget to like, share, and subscribe, and of course click on the bell icon to be notified for future SciTech Tech videos. Till the next tech, goodbye.